Hey everyone, hope you are doing well. Today I'm going to teach you the proof of differentiating e to the power of x. So if you didn't know, e to the power of x differentiated is e to the power of x. Now, don't worry, it hasn't ruined the video because you still need to go over the proof. But we take some of these things for granted day to day, so you don't have to prove everything you use in mathematics unless you're specifically asked to prove it. There's plenty of things we take for granted or do day to day, and we don't necessarily have to prove them. But I thought it'd be good just to be kind of complete to explain why e to the power of x differentiated is e to the power of x. So this is the proof. It's one of our less complicated proofs I've been through, and you can tell that just because it's on one page. I've highlighted a couple of key steps here. Now I'm going to cover a couple of these things throughout the video, so like differentiation from first principles, the exponent rule, and that stands for L'Hopital's rule. And when I say cover them, I'll touch on them, I'll say what I'm using, but I won't break down into a lot of detail like what they are. Like I'm not going to prove these things because they're already proven, so we can kind of use them in other proofs, if that makes sense. So I will touch on them. I'll probably show a definition and a little bit of explanation in my editing. And yeah, I'm mainly going to focus on the proof because I don't want to digress into, for example, the exponent rule, why that is, or differentiation from first principles, where that is. I want to stay focused on the actual proof. But if you do have comments or questions, you can let me know down below. I'll do my best to get back to you there. I can't promise that I can answer everything, but I'll do my best and hopefully I can get back to you with an answer. So finally, starting with the proof, I'm going to explain all these steps, starting with letting f of x equal e to the power of x. So what does this mean? We've basically let our function of x equal e to the power of x. So we just defined our function. That's all we've done for the first step. Next, I bring in differentiation from first principles. So that's why I've done the FP, and I've just literally brought that in. And that is f dash of x is equal to the limit as h tends to 0 of f of x plus h minus f of x over h. And I suppose the point is that, for differentiating from first principles, we've got 2 points that we're putting into our function. And as h tends to 0, so this gets smaller and smaller, these points get like closer and closer. But you don't have to worry too much about that. You can kind of learn that separately. All you need to know for this proof is that we're going to take the principle of differentiation from first principles, and then we're going to sub in our function to show what our function is differentiated. So shoving in our function into the differentiation from first principles, f dash of x is going to be equal to the limit as h tends to 0 of e to the power of x plus h. So we've done the function of x plus h minus the original function f of x, so e to the power of x, all over h. So all we've done is define our function, define, or I guess write out differentiation from first principles, and we've shoved our function into that. So nice and simple so far. Now here I've done dash or star ER for the exponent rule, and that is e to the power of m plus n is equal to e to the power of m times e to the power of n. So you can rewrite this to this. And that's important because we want to rewrite this e to the power of x plus h. Now in proofs, you kind of want to rewrite or redo things a bit because it will lead to an easier way of simplification later, or you'll be able to bring out certain parts that you can kind of get rid of. So we're basically rewriting it for convenience because it's gonna continue the proof and get us to that final answer. So now we've used the exponent rule, you can see our e to the power of x plus h has become e to the power of x times e to the power of h. We've still got our minus e to the power of x, and we're still all over h. So all we've done is use that exponent rule, and we've used it on this to get to this. Now another thing I did from here to here, now we do look at L'Hopital's rule, but I guess that's technically more this step. But the main thing I did from here to here is I took out e to the power of x. Now I'm able to do that because the limit as h tends to 0 is not going to affect e to the power of x. So you can imagine as h changes, x isn't being effective. So it's effectively a constant. So, or for this purposes anyway, or for these purposes, so we bring out e to the power of x. So that leaves us with the limit as h tends to 0 of e to the power of h, because we took e to the power of x here, minus 1, because we had minus e to the power of x here. So e to the power of h minus 1, because we've taken, I guess, a factor of e to the power of x out from these two terms on the top. So it's e to the power of h minus 1 over h. That's what we're left with. Ignore the red for now. Now for the next step, this part here just becomes 1. That's why I've highlighted it in red. And the LHR stands for L'Hopital's rule, because you can actually prove this with L'Hopital's rule, but I think you can prove it in a few other ways as well. But we've basically taken the fact that the limit as h tends to 0 of e to the power of h minus 1 over h is equal to 1. So we've taken that already known fact, so we've basically substituted this out for 1. So that gives us e to the power of x, or e to the power of x here, times 1. E to the power of x times 1 is just e to the power of x. So I feel like that's quite a nice and simple proof. I'll pop up some more details for all of these in the edit. You don't need to kind of like do the proofs for these proofs, I guess, unless you're asked to. You should be able to just use them as part of this proof. And yeah, that's basically how you prove this. So I hope that helped. If you do have comments or questions, let me know down below. And if you've made it this far, I really appreciate you watching, because I'm trying to get my watch time up. So very much appreciated. And best of luck with your maths.